So in this video, we're going to start talking about the third type of conic section, ellipses. Now, an ellipse is defined as the set of all points on a curve such that the sum of the distances from each of the two foci is the same. Now, foci just means two focus points. It's the plural of focus, it's foci. The ellipse can either be elongated horizontally or it can be elongated vertically. And that's all going to be dependent on which one of your denominators is the larger value. So a couple things to notice. First thing, HK is the center. Okay, and that's that little red point right here. That is our center. Okay, A is the length of the semi-major axis. So an ellipse is made up of two axes, and I'm going to draw this up on the top here. If your ellipse is more elongated horizontally, that would be your major axis, and then it would be crossed with your minor axis, okay? However, when we talk about the semi-major axis, the idea here, semi mathematically means half. So semicircle, things like that, that's just half a circle. So semi-major axis means half the major axis. So in our picture here, this green little part right here from the center all the way to the edge of the ellipse, this is your A value, okay? Then we have what's called the B value, which is your semi-minor axis length, okay? I think I just spelled length horribly wrong, so let me try that again. That looks slightly better. Okay, so the semi-minor axis length is from the center to the closer edge, if that makes sense in terms of one of the axes is going to be shorter, so the edge will be closer to the center. So that's your B value. All right, and then things to notice, all right, your A value is always greater than your B value. So in this particular graph, we're elongated horizontally, which means that the A value is greater, and it would be underneath the X portion of the ellipse equation. We can also have a graph that is more elongated vertically, okay, in which case your minor axis would be horizontal. In that equation, your A and your B values would be flip-flopped here in terms of the A value would be underneath Y to create the longer axis vertically, and the B value would be underneath X to create the shorter horizontal axis, the shorter minor axis, okay? C is the last piece here, and that is your focal length, okay? So focal length is going to be from the center to either of the two foci. The foci are equidistant from the center, so either one of them will get you the same focal length. And one other piece of information to know in terms of how A, B, and C are related, C squared is equal to A squared minus B squared. Be very careful with that relationship. All right, so the rest of this video, we're going to be going through and graphing these equations and then identifying certain characteristics. So first equation here. Center is going to be HK. So it's what's attached to X, but always do the opposite. What's attached to Y, do the opposite. It's basically the same thing that we've seen with the parabolas and the circles we've been talking about. So center here is going to be positive 4, negative 2. Your A value, remember, is going to be one of these two denominators and do the square root. So Remembering that your a value is the larger one, this is a squared, this is b squared. So your a value is 5, your b value is 4, okay? So let's actually start graphing this thing out. I'm going to start by graphing the center. So I'm going to go to 4, -2, right there. Now, 16 is underneath x. My b value is 4, which means along the x-axis, I'm going to count, or along the horizontal axis here, I'm going to count 4 to the right and 4 to the left. So 1, 2, 3, 4. 1, 2, 3, 4. Now, underneath y, I had 25, which turns into an a value of 5. So that means from the center, I'm going to count up 5 and down 5 because I want to be more elongated vertically here since the larger number is underneath the y part of the equation. So 2, 3, 4, 5 here. I made a little extra mark that I want to take out. Okay. Then 1, 2, 3, 4, 5. All right. Now, these 4 points that we've just marked, the absolute highest, absolute lowest, furthest left, and furthest right points, these are called the vertices. So I'm going to actually take a second and figure out where those points are so I can label them all out in terms of identifying them. So we've got 4, 3, and 4, what would that be, -7, okay? And then we have, let's see, 5, 6, 7, 8, -2, and 0, -2. All right, so again, your vertices are just when you count this out, where those highest and lowest points are and the furthest left, furthest right points are. Now, one thing when you're going to try and graph this is you probably want to be careful not to hold it down because I'm pretty sure Notability cannot snap an ellipse. It can snap a circle in place, but I don't think it can snap an ellipse. So just do your best to make it kind of oval looking, that ellipse shape, elliptical. All right, the last thing we want to do is identify our 2 foci. And basically we're going to find our focal distance here. So remembering that c squared is equal to a squared minus b squared. And we have our a squared and b squared values right here. So take your 2 denominators and subtract them. So 25 minus 16, that gives me a c squared value of 9, which means c is equal to 3. So from the center, I'm going to count up and down 3 units. And the reason I'm counting it vertically is because that's the larger denominator is attached to y. So it's more elongated vertically. So that's my major axis. So 1, 2, 3, there is one of my focal points. Let's go ahead and find the other one. 1, 2, and 3. And what I'm going to ask you guys to do is actually identify what those points are. So from the center, we added 3 to our y value, and then we subtracted 3 from our y value to get those 2 foci. So we've got 4, +1, and we would have 4, -5. All right. So that is how you graph an ellipse. Now this particular ellipse was, again, more elongated vertically than it was horizontally. All right, let's take a look at problem number 2 and see what we got here. All right, problem number 2, we have a center of, well, nothing is attached to x, so we count that as 0. Center is 0, -8. Our larger denominator is a squared. Our smaller denominator is b squared. So a is going to be 4, b is going to be 1. So let's go ahead and graph that out so we can find our vertices. So 0, -8. All right, there's my center. Now, because my larger denominator was under x, I want to count my a value horizontally. So from the center, I'm going to count 4 units to the right, 4 units to the left. Okay, so that's going to elongate me on the horizontal. And then my b value is 1. So from the center, I am only going to count up 1 and down 1. This is a seriously squished ellipse. All right. Really, really elongated. So let's go ahead and identify these vertices. So let's see, from the center, I had to move left and right 4. So 4, -8, -4, -8. I also needed to move up 1 and down 1. So 0, -7, and 0, -9. All right, so those are your 2 vertices. I'm sorry, 4 vertices. I can count, really. All right. Now, separately, let's see how my counting skills go when I try to find my 2 foci. So first things first, we're going to do c squared is equal to a squared minus b squared. So c squared is equal to 16 minus 1, which means c squared is equal to 15, which means c is equal to the square root of 15. All right. Now, one thing to notice with both these first 2 problems, and this will happen with all of them, c is your focal length, so c has to be positive. Be careful with that. Don't try and put it as a negative. Not for the c value. Your foci can be negative, but not the c value. All right. Now, I don't know about you guys, but trying to figure out how to count root 15 isn't going to really work in my brain. So c is approximately equal to 3.87. Now I'm going to really zoom in on this picture, and I need to count to the left and right 3.87. So 1, 2, 3, almost all the way to that vertex, right? The farthest right. And I'm going to do the same thing. 1, 2, 3, almost all the way to the far left. Okay. So yeah, that's, we got to figure out where those little red points are. So from the center, we had to move to the left and right root 15. So that means we had to affect our x value. So 0 plus root 15 is going to be root 15 -8. And then 0 minus root 15 would be negative root 15 -8. So there's my 2 foci for that problem. All right, 2 more to go. Let's see what comes up with problem number 3 here. All right, let's find a center. Center here is going to be -2 and -4. Okay, we've got a squared here and b squared there. So my a value is 7, my b value is 3. Let's go ahead and graph this. So -2, -4. The a value, the larger denominator, is underneath x, so I'm going to count 7 left and right off of my center, and I'm going to count 3 up and down. So 2, 7. That makes 7 there. All right, and then 3 up and down. So 1, 2, 3, 1, 2, 3. Okay. So to get my vertices, I can actually just look at my points, or if I think about, I've changed this x value 7 units, either left or right. So -2 plus 7 would be, what would that be, 5, -4. -2 minus 7 would be -9, -4. And then if I leave the x value alone, I had to add or subtract 3 to the y value. So -2, -1 if I add 3, and -2, -7 if I subtract 3. All right, so go ahead and do what you can to make an elliptical shape. Okay. There we go, not too bad. All right, last thing here for this one is to find the 2 foci. So let's see, c squared is equal to a squared minus b squared. So c squared is equal to 40, which means c is equal to the square root of 40, which would be better known as 2 root 10. And again, I don't know what that is off the top of my head other than 6 point something. And the reason I know it's 6 point something is because it's a little bit bigger than 36 there. 6.32. So your major axis is the horizontal one. So let's go ahead and from the center count 6.32 horizontally. So 1, 2, 3, 4, 5, 6.32. 3, 4, 5, 6.32-ish. Okay. And I want to identify my two foci. Now, in this case, it's going to look a little bit weird, but basically what I'm going to do is, because I was changing things horizontally, I added 2 root 10 to my x value to get this foci, focal point, and then I subtracted 2 root 10 from my x value to get that focal point. So that's exactly what I'm going to write. -2 plus 2 root 10, -4, and -2 minus 2 root 10, -4. All right. Yes, they look weird, but that's the exact location of those two foci. All right, problem number 4, last one on this page, and then this video will be cut and I will make a separate video for page 2. Let's see what we've got here. Center first, -5, 0. We've got b squared here and a squared here. Remember, a squared is always the bigger number. All right, so let's see, we've got 6 and we've got 2. So let's graph this thing. Let's see, -5, 0. My x denominator was 4, so that means my b value is 2. So I'm going to go ahead and count 2 to the left and the right. Okay, so 1, 2. Made a little extra mark there, so I'm going to go ahead and take it out so I don't think it's like one of the focal points or something weird like that. There's my 2. Okay. And then underneath my y, I had 36, which translates into 6. So I need to count up and down 6 units from that center. So 6 up, 6 down. And again, this is a relatively narrow, or I don't know if you want to call it squished. Whoops. Let me try and graph that just one more time there. Whoa, that's just not looking right. Slightly better. Let's see if I can get that part. It's all right. All right, so let's go ahead and identify those vertices. So on the x-axis, we added or subtracted 2 to our x value. So -7, 0 and -3, 0. And on the y-axis, we added or subtracted 6 for that vertical axis there. So -5, 6 and -5, -6. So those are my 4 vertices. Let's go ahead and find 2 foci. So c squared is going to equal 36 minus 4. That's the a squared minus b squared. So c squared is going to equal 32, which means c is equal to square root of 32. Let's go ahead and reduce that. I believe it's 4 root 2. Yeah, it's 16 times 2. Yep. So 4 root 2, not terribly helpful when I'm trying to actually graph it. So the square root of 32 is 5.66. All right. So on my major axis here, which is the vertical one, I'm going to count from the center 5.66 up and 5.66 down, which puts me almost at those 2 vertices there, but not quite. So on the x values, I did not change from -5, but the y values, I took 0 plus 4 root 2, and I took 0 minus 4 root 2. So weird, I know they might be, and if you have questions or concerns, it would be a good idea to send me any. Send me messages in Canvas or send me emails with whatever questions you have. The second video is going to be reversing this process.